So thank you very much, Nadja, for this really kind introduction. And welcome to my presentation about enhancing glass plates to 3D printing with glass. Most of the stuff Nadja already said. I'm a civil engineer, and yes, I'm a 3D printing nerd. I'm also doing some glass stuff, but also plastic and geopolymers. And I have also some experience in high temperature processing of glass, like bending and also testing. And also another focus of myself is the structural optimization, which I'll touch on later. To start, I'd like to introduce to you the tree exchange approach of the Glass Competence Center with 3 focal areas. There's the generations, the industry, and the handicraft. And so I will present it to you at the example of spray printing glass. That's the first project I made at the Glass Competence Center. And it starts with the industry. They came to us with a demand for the question. They have a lot of customers. They want to have walls like this or curtains out of glass, something like this. And they asked, why can we spray it? I don't know if you're any glass experts, but yes, it sounds quite stupid. And the physical properties of glass are not suitable for spraying. And also this was the first attempt. It doesn't work. So our head of the Glass Competence Center made a team out of a lot different people. And the youngest one was myself with the age of 19, and the oldest one up to the age of 60. And it was really good to have some guys into the team with non-knowledge and non-biasedness. So you can have myself, I had some stupid ideas, but sometimes it was not that stupid and was integrated into the workflow of this technique. And so we developed a workflow, and it worked after a few attempts to spray print glass. And also crucial was the handicraft. So we had a girl named Maria. She is a glass apparatus builder, something like a glass blower. And it's really crazy. She knows how the flame, which temperature it has. She knows the temperature of the glass, and she knows how to heat it up. So it was really crucial for the parameter tuning. So we had over 40 parameters, and in a fast time, we found the right parameters for these results. I have it also here. So we made translucent parts, we spread translucent parts, also transparent parts, white parts, yellow parts, and red parts, so all colors, and also all sizes. We spread up to a height of 4 centimeters, and also some lower lines, as you can see here. And why this tree exchange approach? For this, from the idea to the result, we just needed six months, and below 20,000 years for materials and personnel. So with a few people and a low amount of money, we made some big innovations just because we had some different approaches and the experience from the handicraft. So maybe if you strive to do an innovation on yourself, bring a stupid idea to life, maybe focus on some guys from the handicraft sector or some younger and older people. And for the end of the first part of my presentation, I have some visions what we want to do with this technique in the building industry.
That's it.
So the second part is about glass 3D printing with the FDM process. This process is quite old. So the white picture is from 2015. And what's new this year, we managed to print directly onto glass plates. So this looks like this, or I will give it a word. But before working with it, I developed a new test for 2D printed brittle materials. And it's a 4-point bending test with a new geometry. And the first question, just put your hands up. Who thinks that the 90-degree samples on the top left is the strongest one? Who thinks the 0-degree samples? And the 45-degree samples? So it's quite interesting that the 90-degree samples, so the first one, was the strongest one. It's not the layer orientation which matters with glass, it's more the heat treatment. So if you're getting the white heat treatment, as at the top part, the left part, you have a good connection and the layer notches are not decisive. As you can see, the cracks are not going along the layers. And for some comparison, we made the experiment 2 is with the raw material strings. They were a lot smaller, so you need to have some size effect to look at some size effectors. But another comparison maybe, so 4mm window glass in the same setup has a mean value of 50 to 90 megapascals. So the strength of the AM glass is suitable for some construction application. What I did is structural optimization of glass plates in the building industry, like on skyscrapers, with topology optimization, shape optimization. And I developed some different designs with some similar performance level. So on the left hand, you can see the material savings in comparison to traditional flat glasses. And for a case study in Frankfurt here, and the material savings are around 60 mass %. And for other bearings and other loads, we get savings up to 70%. Why? Because glass plates, as you can see here, without stiffening structures, which are loaded perpendicular to the area, are quite weak. So we stiffen it to make it to bring the loads into the bearings. Another approach for enhancing glass plates is some are fixations, which are load guided, or also the interior. So maybe some faucets, or also we made it already, some little shelves like this one. And also what's also possible for enhancing glass plates, you can see it at the exhibition below, so some customizations, so patterns or logos and some letters. The most asked questions in the glass 2D printing is are the environmental opportunities. I would say, yeah, there are a lot of environmental opportunities, but only if this process can be integrated into an existing glass manufacturing process like tempering. Otherwise, you need to heat this plate up to over 600 degrees, which is a huge impact on the footprint of this material. So this will be the crucial part in the next year for this technology. to bring it in larger scales and into the industry. Yeah, that's it. I have to thank you, some guys who helped me in this time, and I'm looking forward to a really interesting discussion with you guys.
Thank you. We have time for 2 questions, and I think we can start right here.
Good. Thanks for your talk. So you showed us these glass panels with increased stiffness. So how much is it because you printed a stringer on top of it, and how much does the stress of the shrinkage, the pre-tension, impact the strength?
So we don't doesn't consider, or I doesn't consider. We don't consider the pre-stress. So it's just a stiffening structure we consider in the calculations.
But it should be beneficial as well, right? Or is it the other way around?
So the residual stresses are a more critical point in glass because you can't control that easily.
Yeah. So it's like you are tensioning the substrate with a stringer. So this could be beneficial as well, right?
Yeah, I think it's more easier for glass to pre-stress it with temperature. And I think that's the more familiar approach in glass plates, and it's kind of heavy to pre-stress it with the 3D printing process. Thank you.
Is there any other questions? Okay, so we will move on with our next speaker. Thank you very much.